next question is a question from 2006. And here is the question. 2006 Zone B question 1. I summarize the question for you. I am told that there is a monopsony. The monopsony faces an upward sloping labor supply. You already know that. A monopsony has to face an upward sloping labor supply. And the labor supply function of the monopsony is given as 100 plus L. Again, the question doesn't require you to draw diagrams, but always try to give yourself, at least while you are practicing, you don't need to do it in the exam, but while you are practicing, give yourself a diagram that will help you understand. 100 plus L means if this is 100, 100 plus L looks like this. This is your labor supply function. Wages here, labor here. I am a monopsony. I face this labor supply function. If I want to hire more units of labor, I have to pay higher wages. That's what this function says. The product price is fixed at P is equal to 200. What does it mean? What is the assumption about the output market? If product price is fixed at 200, it means that I am a price taker in the output market. I am in a perfectly competitive output market. So price is here, output is here Y, then 200. This is my demand function. Okay, this is the supply of labor function. This is my demand function. I am a perfectly competitive firm. Finally, the production function is given to me as YL. Look, I told you in general, if I suspend the assumption that you are both a price taker in the input and output market, I will give you a one input production function. One input production function. YL is equal to L. So my production function, how does it look like? It looks like this. Y here, L here. Looks like this. This is L. Okay, I don't need to draw this diagram. I'm just drawing them so as to get you a better understanding of what's going on. First question, standard. Find the profit maximizing amount of labor to employ and the resulting wage and profit. I could have asked this question to you in another way. Find the unconditional demand for labor. Profit maximizing amount of labor is the unconditional demand for labor. I could have asked you for the unconditional demand for labor. Okay, profit maximizing demand for labor. What is the problem I am solving? Maximize profit with respect to labor. How will I solve it? Next step, d pi over dl. Whatever I get, I'll set it equal to 0. Solve for L star. I know that. Which means, in order to do this, I must get my profit function in terms of labor. Follow the logic of the solution. I need to do this, so I must get this. Let me do that. Profit as a function of labor. Revenue minus cost. What is my revenue? Price times output. Price times output. So 200, which is my price, times output. I don't want to write my output. I want to get it as a function of L. Whenever I am looking for unconditional demand, wherever I see output, I replace it with my production. Because I want a function of L. So 200Y, Y is just L. So 200L. This is my revenue as a function of labor. Minus cost. Labor is the only variable involved, only factor of production involved. If I hire L units of labor, how much do I pay to hire them? WL. Okay? This is the important part. I am a monopoly. If I hire L, I have to pay a wage according to my supply function. So W, L times W is L times 100 plus L. Please note that this is your total expenditure. Okay, and this is your total revenue in terms of labor. Okay, differentiate. Once you get this function as a function of L, you already know your next step. You will differentiate d pi over dl. Let me do that. I'll get 200 minus 100 plus 12. just differentiate. This is pretty simple differentiation, but understand what I am trying to do. This fella here is nothing but your marginal revenue product of labor, MRPL. Why is it the MRPL? Notice, price is equal to, or BMPL, because the same thing. In perfectly competitive market, MRPL and BMPL is the same. BMPL. Okay? Why? Because the marginal revenue is equal to 200 here, 200P, and your marginal product of labor, notice in this particular case, dy over dl is equal to 1. So this is 200 times 1 really. 200 is the price, this is the marginal product of labor. Therefore this fella is the MRPL or the BMPL on the left. Right? This is the value generated, the extra revenue generated by hiring one more unit of labor. Why? Because one more unit of labor will produce 1 unit of output. That output will sell for $200. Therefore, the extra revenue generated by hiring one more unit of output is 200. That is the marginal revenue product, or in this particular case, value of marginal product. And this fella here is nothing but the derivative of the total expenditure with respect to labor. This is the marginal expenditure. This is MRPL, this is MEL. Okay, BMPL or MRPL, whichever way you go. Okay, and this must be equal to 0, which gives you the familiar condition that you have seen before. MRPL is equal to MEL. Okay, same thing. MRPL is equal to MEL. In other words, 200 is equal to 100 plus 2L, L star is equal to 50. This is the profit maximizing demand for labor. In other words, this is the unconditional demand for labor. Diagrammatically, ladies and gentlemen, this is what is going on. I want to show you how I can equate MRPL and MEL here. Here I have wages, MPL, MRPL, all of the rest. MEL, all of these fellas. Here I have L. What is my MRPL? 200. Flat. Normally MRPL is downward sloping, but that's because your production function is, here the production function is a straight line like this. So this is your MRPL, 200. You have found out, huh? This is your MRPL. What is your MEL? MEL is 100 plus 2L. 100 plus 2L. This is MEL. 100 plus 2L. What is your supply curve? 100 plus L. Your supply curve is 100 plus L. Same intercept, but flat. This is WL. This is your supply curve of labor. 100 plus L. What is the profit maximizing demand for labor? Wherever MRPL is equal to MEL here. This color, L star here, is this is the question also asks you, what is the equilibrium wage in the market? What am I asking you? To hire 50 units of labor, how much must I pay? Well, this is my labor supply curve. I want 50 units of labor. I go and substitute into my labor supply function. So in other words, the wage I must pay to hire 50 units of labor given by my supply function, 100 plus 50, 150. In terms of the diagram, I want these many units of labor. This is my supply curve, the red line. Therefore, this fella is 100. This is the wage. This fella is 150. I substitute the labor into my. What is my profit? Yeah, you won't do that's pretty simple. You already have a profit function in terms of L. Just take L, substitute here, substitute here, substitute here. That will be your profit. That will be your profit column. 200 times 50 minus L times 150. Okay. That's your profit column. 10,000, 150 times 50, 7,500. The answer should be 2,500. Okay, this is part A of the question. Part B of the question. Okay, so whenever you see a profit maximizing demand, you are being asked, when you practicing questions, In order to cement your understanding, draw these diagrams. It will help you. It will help you see what's going on. Okay. Part B of the question is slightly more interesting. Now, the question tells you, assume now that the amount of labor the monopsonist is able to attract. Previously, the monopsonist was facing a supply curve like this. Whenever he wanted a certain amount of labor, all he needed to do was to pay the wage required to hire that many units of labor. Now the question tells you this is no longer the case. Assume now that the amount of labor the monopsonist is able to attract depends not just on wages, but also on the level of recruitment expenses R. In this manner, L, the amount of labor you can hire, is a function of W, R, which is equal to minus 100 plus W plus R half. R. This is what the question is. R is the level of recruitment expenses. The idea here is that if you want to hire people to work for you, you better spend more money. In other words, hold your interview in Shangri-La rather than say at Hotel 81 or something like that. That's what it's going on. Okay? Depends positively on the level of recruitment. The question asks you, determine the optimal level of W star R. Just so you are not confused with interest rates, let me write it. W star R. I'm not asking you. Previously the amount of labor you could hire depended on what? This is WL is equal to 100 plus L, right? If I wanted to write it as L is equal to W minus 100, previously the amount of labor you could hire depended only on the W minus. This was the function before. Now the function has become L, W, R minus 100. Now I want to find the optimal level of wages and optimal level of recruitment. Notice, I am not asking you for the conditional demand for labor and unconditional demand for labor. I am just asking you for the optimal level of those two variables, W and R. W and R are not factors of production. What is the optimal level of wages I must offer? What is the optimal level of recruitment expenses I must offer? I haven't told you, we haven't discussed this. But clearly we have discussed what it means for something. This is what I mean by speaking to the basic principles of equation. Optimal level of two variables for a firm. What does it mean? Profit maximizing level of these variables for the firm. So if I want to find the optimal level of these two variables, I must be maximizing profit with respect to W and R. No other way. If I am finding the optimal level of W and R, it means I am finding the profit maximizing level of W and R. In other words, I am choosing W and choosing R to maximize. Once I understand this is what I am doing, there is only one way to do it. My next step is bound to be d pi over dw. Whatever I get, I will set it equal to 0. Equation 1. d pi over dr. Whatever I get, I'll set it equal to 0. Equation 2. Solve simultaneously, I'll get W star R star. Only one way. Once I notice this is the problem, there is only one approach to the solution. And once you understand that this is the only approach to the solution, you know that to calculate this, your profit function must be a function of W, otherwise you can't differentiate. To calculate this, your profit function must be a function of R, otherwise you can't differentiate. Okay, that's the idea. Therefore, all I need to do is to get a profit function. This is the central idea. Once I get this, rest of it. How do I get a profit function in terms of W and R? Here we go. Okay. Profit, right? Revenue minus cost, right? Revenue is price, which is 200 fixed, times output. I don't want output ever. If it's the unconditional demand related question, I want to replace not Y but L. And you also notice the reason I am replacing it with L is because I know L itself is a function of W and R. Later I will put this in. Okay, that's the idea. I'm getting the whole function in terms of W. 200 times L, this is my revenue in terms of labor, minus W times L. This is the cost of hiring L units of labor, minus, don't forget this, huh? This is the expenditure, okay, this is the expenditure of hiring L units of labor. This is crucial. It's very likely you will miss out R if you don't pay attention to what's going on. Revenue minus expenditure. Revenue minus expenditure. This is the wage-related expenditure. This is the recruitment-related expenditure. Here my expenditure has two components, W and R. Alright. I need it in terms. I have an R here, I have a W here. But I notice that L is a function of W and R as well. So all I need to do is to replace L with W. Wherever there is L, I replace it with